like how to connect to Istio, like that is running into different clusters. So that's something that he will be explaining. Like he will also walk through us on the things like uh, why do we need Istio, like a service mesh, and why this specific use case, right? So why do we need to connect to clusters? So I have experienced some of the things in my past project experience, but maybe he will explain more, and so that you can understand that maybe you would also have similar use cases and understand from him, and um, get things implemented in similar pattern. So welcome Vishnu. Thanks for joining us today. He's also from Canada, and it is like early morning there. So I really appreciate you joining us in these early hours. Thanks Vishnu for joining us today.
Yeah.
Yeah.
Thanks for inviting me. It's nice to meet you all, and I think I know a few of them like from LinkedIn post. So yeah, I'm glad to have this conversation. Um, Let me share my screen. So we'll be talking about like building REST-lane multi-region service mesh with Istio and Volt. Before we continue, like I'll give you an introduction about myself. Um, like Vishnu told, my name is also like Vishnu. I work as like a freelancer. Codebase Analytics is like my own Canadian corporation I use for billing my clients. I work in TopTal, Brain Trust. I also have like contracts with companies like Esla Exotica and few other banks in the US East Coast and West Coast. So mainly I do freelance work. I have some experience in data operations as well as DevOps and some experience in pen testing. So yeah, that's all about me. So today's agenda, like we'll go through like an introduction about like zero trust, what are the challenges we face in the multi-cluster Kubernetes, why we choose Istio multi-primary. There are like different networks when it comes to the Istio. So for this today's demo purpose, I just choose Istio multi-primary. Then I'll also show you like how we integrate HashiCorp Vault as like a central CA, because when we do Istio multi-primary, like one of the prerequisites is like you have to enable the trust using like a CA certificate. So if you go and look at the Istio documentation, what they suggest is like they have like a sample script where you generate like a root C using the open SSL commands. So instead of that, we'll be using Vault as like a central CA, and I'll show you like a demo, like the whole setup. So first we'll go with the introduction, like why zero trust. So zero trust, like it assumes like nothing inside or outside your network can be trusted by default. So instead like it says like trust me continuously, like verified. This is especially like critical like in Kubernetes, like where workloads are ephemeral, nodes scale dynamically, and microservices communicate across highly distributed architecture. And even in cyber attacks, like for example, you have an exposed there is an RCE for a web application, and when an attacker enter through the RCE, RCE means remote code execution. So when an attacker enter to the let's say a pod or something, what they try to do is like they started lateral movement within the clusters. So we have to make sure like the service to some service communication is like secure, and that's a urgent need, like zero trust security like in Kubernetes. So one second. Then why multi-cluster? Like what are the challenges we face in the multi-cluster? So when an organization scales, like a single Kubernetes cluster may not suffice to meet the growing demands of performance, availability, and security. So multi-cluster like provide like a way to distribute your workloads across region, improve fault tolerance. It's also comply with data sovereignty and requirements. Like for example, like if you look at the region in the Europe, like they have to follow GDPR. if you are in the US, in the California, they have to follow the California data rules and regulations. If you go to the region like Russia, they have like their own unique data regulations, especially like when you work in the telecom or like in the banks. So there will be need like a company or like organization needs like multi-cluster. What are the main challenges we face in the multi-cluster? So I'll, one second, let me. So main of the challenges is like in multi-cluster, like how we do like service discovery across the clusters. Like how do a service in one cluster discover and securely communicate with the service in another cluster um, without like a unified control plane or
So
like
I
a powerful
think you
configuration?
might have to
Yeah.
go back to the one slide up.
Oh, sorry. Yeah.
Yeah, nice.
Yeah. So in here, like securing communication like without like manual configuration. So you have to find a way to do the trust between the clusters through like a mutual TLS or any other encryption mechanism you can use. um, you don't need like to add like a service entry like for each of the services because like in a single cluster maybe you have like hundreds of Kubernetes services you operate, and when you have like multiple clusters you maybe like end up with like 200 300 service microservices. So you don't want to like expose each of the services through like a service entry. So that's why like we have like we can overcome this problem through Istio. Then another challenge will be like like how we maintain the compliance policy like across the cluster. Like um, no workload in any cluster is allowed to run like privileged containers, enforcing network policies like that. And also like how we manage like sensitive data like and secrets between these two clusters. That's why like we use like tools like Ashika Vault, or in if you're using like AWS or GCP or Azure, like they have like their own secret management tool, and where we can also integrate with the secret management tool within your cluster. And also like some open source tools are there like sealed secrets. Sealed secrets is like something you have installed the sealed secrets components in your cluster, and you have exposed the secrets in a encrypted way. Even you can commit in the Git, and it won't be like able to like crack it. Only it will work inside the cluster. So there are like open source tools as well in order to do this. So these are the like challenges like we face like mainly in the multi-cluster setup. Um, one second. So why Istio multi-primary? First, I'll like talk about like the why we choose Istio like to manage the setup like because it's one of the service mesh when we compare with Linkerd or any other tools. Istio is like more powerful. It is a bit heavy, but it provides like a way to manage your microservices, networking, security, observability. So there are a lot of things we can do with Istio. Here, the purpose is like traffic management. Like you have advanced routing, traffic splitting. You can configure like support of canary deployments, blue green deployments, A/B testing. Then you can implement, like I said, like mutual TLS, RBAC. There are a lot of ways we can use Istio for this. Um, so the like one of the use case, like for example, geographical description. Like you have an organization, you have operate in, for example, Meta. You have a data center in the US East region, and you have data center in the Europe region. So and both regions have like the same services they deploy. So how they communicate each other. So that's where like where they use. I'm not specifying like meaning they means like Meta or Google, but generally like organization use Istio for this purpose, because each data center have like their own different networks to operate each other, and it also support like communication between these two regions. Then when you talk about like multi-primary, like each cluster will have independent control planes where like you can scale across the multiple clusters like in different networks. um, so each cluster can operate like an independent control line. It will reduce the latency, like ensuring that outage will be like only to one network, which do not impact on the others. Then we have like scalability. Like for example, you may use AWS, you may use Azure, so you can even put Istio in the middle and communicate with each other easily. Um, and it's also support like multi-network communication. It will be like you can like have separate networks, and each of the separate networks can be easily discovered and communicate within each other with Istio. Um, let me. So this is like the uh, diagram looks like. So here we have like a central mesh. So we have like two clusters. Each clusters have like a different network configurations, and we connect these two network in like a single mesh. So even within the two clusters, or like when we have like multiple clusters, we can have like different mesh with different network configurations. That can be even like much complex in order to manage, but it can be done with the Istio setup. So I'll give you like a high level view of what are the components of this. So mainly here, when we talk about like Istio is like a control plane, like it manages the service discovery, traffic management, and the security of the that respective cluster. It syncs configurations across the mesh to maintain consistency. Gateway means like it handle ingress and egress traffic between the clusters over their respective network. It enables like a secure communication for cross-cluster service discovery. Here, the API server is more like act as like a control plane, like a control point for your configuration and your endpoint communication, like for Kubernetes resources in the cluster. Services are like your normal microservices operating in the cluster, and you can deploy the same service in both clusters, and the both clusters will be able to communicate each other. Like for example, I am deploying Nginx, just a scenario. I am deploying Nginx in two clusters, and I have under the service like a REST API. I am calling the Nginx, and it can communicate even if one of the port goes down. It will still communicate to the another port through the Kubernetes services itself. You don't need to like expose it. So that's the main benefit of like this, because the cross cluster communication will be like much easier, and able to discover easier, and even like in a like if something goes down in one of the services or one cluster, your application will be like still up when we are like in this scenario. um, so in order to do this, like there are like some prerequisites. That's where like we do. So each cluster needs to have a trust between, and the trust is basically done through your intermediate CA. So you will be like creating like a root CA, and then you from the root CA you provide like intermediate CA to both clusters, and then from there to workload. So this is the hierarchy structure. And if you like go to this link, they will be like providing like a, let me check if I can show it to you. uh, Let me 1 second. Let me know if you're able to see the certificate management. Are you
Yeah.
able to see this page?
Yes. Yes.
Yeah. So this is like if you go to the Istio documentation, you can see this in there. So what they suggest is like they will be like providing like a default scripts where you can use. If you look at these scripts, it's mostly like manual generation of the certificates. So you will be like creating root key CA, and from there you will be like uh, creating your chains. So but this is not like a production ready. Like even in their setup they will be like telling the following instructions are for demo purpose only. Like for production setup, like use like a production ready such as Ashika Vault. So that's what I'm like trying to do it in here. So let me share the screen back.
Vishnu, we have one question. Like, can we take that question now, or maybe?
Yeah, sure.
Yeah. So can you read that, or you want me to?
The DNS will point to one ingress IP, which is associated with one cluster, right? So yeah, we don't be using ingress like in this scenario. Like for example, you will be like connecting with the same Kubernetes service itself. Like you don't need to go through like an internal load balancer or anything like that. Like for example, when you install, let's say you have a microservice Nginx, you deployed it in both two clusters, and I have another service which I want to communicate with the Nginx. So I'll be like calling that service, the Kubernetes service itself, and I will not be like calling the ingress IP in this scenario. Even like in the multi-purpose. So for example, each of the let's talk about like ingress. So if I am using a gateway, each of this gateway will have like its own unique IP address. So we can also put that unique IP address like in the DNS and point it to the clusters. So even if this gateway goes down, it will be still able to identify like where to route for that service, and the page will be like delivered. So I'll show it in the demo. So I hope that clears.
Okay. Well, like, if there are any follow-up questions, please write down in the chat, or you can just get you as a presenter so that you can also speak up. But maybe let's continue for now.
Yeah.
If there's a follow-up question, we'll take that up as they come.
So yeah, so in this case, like I'll be like doing the whole this scenario like in Vault, like creating like a central CA Vault for the Kubernetes to trust each other, and from there we create like intermediate CA, and the Vault will be like managing the certificates. So let's go to the demo. 1 second. Let me 1 second. Let me share the screen. So let me know like if you are able to see the screen. Are you able to see the screen?
Yes. Yeah. You can see the terminals.
Yeah. So I'll first run this, and then I'll let me show the files. Yeah. So this is the first. I'm doing it in my MacBook. So what I'm trying to do is like I'm creating like a two kind clusters. Like using kind, I'm creating like two clusters, and I have like a custom file which I'll be like using. So this custom file will have the network which I want to use. Like for cluster one, I'll be like using this port subnet. This is the service subnet I'll be using. This is how I'm mapping my ports with the host port and container port. Same for the cluster two. Since it's like a single laptop, so I have to do workaround in order to make it work, because I won't be able to do like use same port to export services, so I have to adjust it. Then I use Metal LB in order to show you like how like in cloud-based scenario, like how you can use that like in the ELB based setup. So here I'm like telling this is the address space I want to use. These are like Metal LB configurations. Um, so here I have like given like two networks where the when I create like a load balancer, it will be like picking it from these networks. So yeah, sometimes like when you so I'll go through also this. So then since I am like working in the like in the laptop, I have to manually like tell the routing like between the two containers, like how we'll be like able to connect. So in a real world scenario, like even if you have like two data centers, like you may need to like connect each other. So like in general scenario, people will be like setting up site-to-site VPN, but even like even for site-to-site VPN, it will be like if you're thinking about like Meta or Google, they won't be like doing site-to-site VPN. They will be having like dedicated like high-speed fiber optic links. They will be like using like SDNs, like software defined networkings. They can also use MPLS. So there are like different ways like companies will be like doing to make both data centers to connect each other. Then I'm just like installing Istio. So this is the first script I just run. So let me share the screen back. So this is a script I just run. So sometimes like you'll see like it was like this error. So I have to fix the validating webhook for this. So all I need to do is like uh, I'm just deleting that validating hook and I'll just rerun the script. Oh, sorry.
So this install script, what that do is essentially like setting up two kind cluster with the Metal LB
Yeah. So
setup.
here, yeah. So basically, I have like two nodes, cluster one and cluster two. I also have Metal LB in place. Oh, sorry.
Mhm.
So you can see both have Metal LB installed. So
Okay.
the next one is like we have to install like Vault. So one second. Let me let me share the file again. I don't have way to share like two screens.
Okay.
Yeah. So the next I'll be like running Vault setup. So this is like the Vault setup. This has nothing to. I'm not talking about the Vault CA. It's just like a how you install Vault in the cluster. So normally you can people usually like for demo purpose people usually do to run it in the Dave version. So here what I'm doing is like I'm running Vault in a TLS mode. I don't want to run it like in the version mode. So what I'm doing is like I'm like basically like downloading the Helm repo for that, and then I'm like creating like a CSR configuration for the certificates. Basically, this is a CSR configuration. So if you look at the CSR configurations, what it does is um, I'm telling like what is the key length. For example, in this case, I just choose 2488 bit for the encryption, then SHA-256 for the algorithm. Then I'm telling like the DN name, that organization name, the common name which we want to use. Then the extensions, like I'm telling that this is not a CA, like this is just like for encryption, digital signing, like that. I'm also putting like the SANs, that's like subject alternate names in this case. Then I'll be like running the commands to like create that CSR, and then create the secret based on the CSR and the Kubernetes setup. So that's what is doing it in here. Then this is the Helm file which I am overriding. I'm telling like I want TLS to be enabled. I don't want to be like disabled. So I'm telling TLS needs to be enabled. Then I'm telling like the env variables uh, to use to, like what which is the CA certificate, which will be the CRT, which will be the key. Then I'm like mounting that TLS certificates. Here I'm telling like HA needs to be enabled. I need 3 replicas. I'm using the default storage raft. Vault have like different storage options. You can use AWS S3, GCS, or even you can use like MySQL. So in this case, I just use a raft. Then even the configuration, I'm like telling like where are the TLS certificates to be. So the path of the storage. Then I'll be like using Helm to install that, and I'll be overriding with the files. After that, once you run the Helm, like you have to go through the unseal process, because Vault what does is like Vault encrypts its data like and logs the access, which is like a sealed state to protect that sensitive information. So you need to have like unseal these to decrypt and access the data. So Vault is initialized like with 1 key share and 1 threshold, meaning like 1 key is enough to unseal. Then the unsealed key is like extracted from the like the installation output, that is like cluster keys.json, and then we use that to unseal the rest of the boards. So the purpose is like mainly like to protect data in case of like unauthorized access or like a restart in this case. So then I'm like telling like to join the raft. So I'll show you like what this is like when it is executing. So let me share the screen again. So when you're looking at, I'm installing Vault in cluster 1 in this case. So here you can see it runs the Helm command, but still waiting. So you can see Vault is like still running, but it doesn't have done the unsealing process. So the script basically does it for us. That's what I explained in the script. So basically it picks the key and it used to unseal it. And now if you look at this, Vault is be running, and you can see this is the leader. These are like the followers in the storage peers. So now what we've done is like you have 2 clusters, cluster 1 and cluster 2, and then you installed Vault in cluster 1. Now the next step is like we want to install the CA setup. So for the CA setup, we have another script. Let me show that. So this is where like I'm telling like some of the variables, like I'm telling like which is the namespace, what will be the Vault address. Here I am just using the, I don't want to expose it to the like a load balancer or anything. I just use the internal Kubernetes service, and you can see I use the HTTPS instead of HTTP. Then I'm like telling the context because we have like two clusters, so I have to switch between them. Then I'm telling like to store like a temporary store where to like store the data, telling the domain name where we want to create the CA certificate, and then specifying the TTL like root TTL, intermediate TTL, and the cert TTL. Then specifying the namespace. For my local setup, I also I created like a cleanup script because in order to do the testing every time, I want to make sure like nothing runs in my local. So I have a cleanup script in place. Then what it does is like I have the cluster keys JSON like saved from our previous script, and then I just use that script to log into the cluster, and then I write a function like every time I don't need to like kubectl exec command to run the vault, so I just write a simple function for that. Then here I'm enabling the PKI. So basically, what it does is like in this case, one second, let me, yeah. So basically, what I'm doing is like I'm creating like the PK in the vault. Then let me. I'm telling like the common name which I want to use. Then I'm telling like the issuer name which I want to use. Telling the TTL timings. Then listing whether this command worked. Um then creating a role. In here, I'm like telling like for the root CA, I'm allowing like any name for that. Then I am like telling like what will be the issuing certificates or the CLR distribution points. So this will be like this plus this endpoints will be like using. These are like normal Vault CA setup. Like if you are familiar with the Vault CA setup, like you will be already knowing this. Then here I'm like creating the intermediate CS certificate. So I'm like telling this is like the alternative name. So here, since I am using in my local, I'm using kind cluster. So I'm using like host.docker internal name, and I'm telling like the key type and key bits for that. Then basically like signing the intermediate certificate. So these are like more like general information related to the vault setup. So yeah, these are like creating roles for the intermediate CA certificate. Here I am again like giving the alternative names. In production, you don't need to do this like allow any name. Like you don't want to do that. You can specify like the specific domain name, but in my case, since I'm like using, I have to even allow localhost and cluster one names in here. So this is like the whole Vault CA setup. So let's run that. So I'm just like generated the certificates, and usually like in your production scenario, you don't need to expose the certificates, and you don't even need to expose the tokens. So this is just to like showing you like what it basically does. So here, like in this scenario, like we created like a root CA. We also created like a intermediate CA, and you can see um, uh, like the configurations. So now what I need to do is like I'll be also installing Istio. So in here, I have like few configuration files, like for one for cluster one and one for cluster two. Then normally you should have only one cross network gateway, but in my scenario, like we have like a single. I'm operating like from the single laptop, so I won't be able to like open the port. I can't use like the same port for exposing the services. So in this case, let me share that again. Uh, so here, basically, if you go and look at the Istio configuration, they don't have like a customized version. What they will be like providing you, like they simply tell you like which network you want to use, but it won't work in a general scenario. Like if you want to try that in your cloud providers, it won't work. So here I'm like telling, okay, apart from the default configuration, I have to add like few other information. So here I'm like telling, I want to add like a retry policy. So if one of the services is like 503 or a gateway error or a connect failure or a fuse stream, I want the traffic instead of like application needs to retry. I'm like configuring the Istio to retry. So it will try 3 attempts within a 5 seconds break. Then the connect timeout will be like 30. And these are like configurations which will be like enabling the DNS. Then these are the ports which will be like open to the Istio ingress gateway. These are like general ports. And then I am exposing 8080 and 8443 for the applications. Then here we will be like telling like the log level, I want to use like a debug. Then here I'm telling this is a mesh ID, this is a cluster one ID, this is the network one ID, and then I am telling like the gateways. So these are the gateway IPs. So this IP you can, for example, in a cloud-based scenario, like you can have elastic IPs or like a static IP, and where you can mention that IP for your ingress gateway load balancer. You don't need to expose it to the public. You can have like internal load balancer for your ingress gateway. In case even if you want to expose it, like I mentioned, if it's like a web services, you can do that. We can expose it like public IP. But normally, most of the times, what happens is like in organizations, when you use this kind of setup, it is more like related to internal services rather than external services. Will be like using like when you have like two, like in a bank you have like hundreds of microservices, and sometimes only cluster one have like certain services and cluster two have like certain services, and we use this setup in order to call between these two services. uh, it's the same for this one here, same configurations, except I have to tweak around with the port part, because since, like I mentioned, we run it in a client cluster. Then again, like I'm telling the gateways and the endpoints where to look for. So here you don't need to, apart from like our normal configurations, like from the AWS security group or the Azure NSGs or Google Firewall, you have the option in Kubernetes when you are exposing a service through the, this is like more like a service load balancer. So you have options to whitelist your IPs. So here I just open it to the public. You don't need to do that like when you are in a cloud-based scenario. You just only whitelist the necessary networks. So both gateways will be only accepting traffic from that. Uh, then we are like exposing it. These are like the cross network gateway. So here this is a port which I'll be using it to communicate between the services. Yeah. So now in normal cloud-based scenario, like you can run this file for both clusters, but in my scenario, like I can't expose the same port. So that's why I have like two files. Then I'm like telling the peer authentication. This is like telling MTLS mode as strict, and the destination rule, like I'm whitelisting it to the default services. And I'm telling like this is the TLS mode which I want to use. So if you look at the installation, it's basically Istio CTL commands, and it will run our configuration files, then basically applying these files, the like simple kubectl information. So let me run it.
Also, while wait for this to run, Vishnu, like the first question that we received was also something similar, related to what you just mentioned. Like this is something more used
Yeah,
in internal, service communication, right? So the question
yeah,
was like, if you have multi-cluster environment and we have an application deployed in both the clusters, right? And if one of them goes down, so how
yeah.
the DNS will get resolved to that? Um,
It Istio will automatically manage it for you. You don't need to worry about that. So if I have like two services with the same name, same port in two clusters, if one of the port goes down, Istio knows like where to route the traffic.
yeah.
So
But
yeah,
the Istio gateway will be something that is running in both the clusters, right? And uh,
yeah,
like where do we map the DNS to? Like if we
yeah.
need to add
So
a record, like how that
yeah,
configuration will look like? Yeah.
yeah. So here you can see like in both clusters, I'll be like using. So if you look at this, this is like the Istio Ingress Gateway. So in both clusters, you have something like this. So you can have like a error code like for both of these IPs. So for example, nginx.example.com, you can point the error code to both of these IPs, and you put your nginx service in both of the clusters, and it will do like round robin traffic. And even if this IP is like not working, when the traffic like reach here, it will serve the traffic to the other cluster as well. And it will automatically done through the Kubernetes services. Yeah, you don't need to like worry about that. So now we have like Istio installed. So if you look at the secrets, so we have each cluster will have like its own CA route as a part of the installation process. So here, when you are like comparing, so I'm just comparing the both of the CSR. So you can see like both of them are like it uses like a separate CS certificate, and now both clusters doesn't have like a connectivity. Like it doesn't have like a communication in place, even though we have run the cross cluster plane and everything. Still, the trust is not there. So this is where like we will be like running our like telling the Istio, instead of this certificate, we have like our own CA certificate which we want to use. So that's what like now I'll be like deleting this secret, and I'll be like creating like a CA certificate which we generated and stored in the vault. So for that, I have another script. Let me show that. Oh, sorry. Uh, um, 1 second. Let me share the screen. Yeah. So I have something like in here. So basically, what it does is like again the cleanup procedure for my local. Then I am like fetching the CA certificate from Vault and then mapping it to a certain folder. The same like fetching root CA, then I'm confirming like the root CA is there, and based on that, I'm like creating like a secret in our Kubernetes clusters, like for both. I can write it like in a for loop or like a separate. I just initially I wrote it in like a for loop, but I thought, okay, maybe it is better to make it understand. So like basically I'm like telling this is the CS cert, which is the intermediate cert, the CA key, this is a cert chain, which is like the full cert chain, and this is a root CA certificate. So we will be like running this in both of the clusters, and now then we can do a like a comparison, like how we did with the MT5 some hash. So let's run that. So basically it would be like deleting these two and creating like a general CA certificate. So now if you look at here in both clusters, I have CS certs, and now we can do like a comparison. We did it for the previous certificates. So basically, so you can see like the certificates is same like for both clusters. Now, like this is like one of the prerequisites which we talked about like earlier, like both clusters should have the same CA set. So now that is in place. The next part is like we want to like enable the endpoint discovery, because we want to tell the clusters um, like how it will be like communicating each other. So the purpose of that is like it generates like a community secrets which contains the service account credentials for the remote cluster. So let me show that command. So this is the command I'll be running. So here I have to mention this server. Normally, like in a cloud-based scenario, you don't need to mention it. It will automatically pick from the kube configurations. So here, what basically this command does is like, um, so it creates like a secret for cluster one, and it applies to cluster two. So this allows the Istio control plane, like in cluster two, to discover and communicate with the endpoints in cluster one. So it's the same command we will be running in the cluster two as well. So now if you look at the secrets, cluster one will have information about like cluster two, and the same wise in cluster two, you will have information about the cluster one. So now let's create like a Nginx service in cluster one, and I'm exposing through cluster IP. So now if we look at the ports, I have an Nginx port. Sorry. I have the Nginx service, and it uses the cluster IP. I'm not using node port or like a load balancer, just the service IP. And if you look at the ports in cluster 2, right now we don't have anything in cluster 2. Let me clear this. So again, telling like in cluster 1 we have Nginx. This is the service, we use cluster IP, and for cluster 2 we don't have anything. So first let's check like whether we can connect to this service just with the services. So normally like I'm like creating like a curl port basically to run curl commands. So now I'm just telling, I'm executing to the curl port and then just calling the HTTP Nginx service. So here we can see like in a normal cluster scenario, this usually works because it's the same cluster. So both of the ports services can communicate each other. Now we want to check whether this will work from cluster 2. So let's delete this port and create the pod in the cluster 2. And I'm doing the same exit command. I'll be doing I'm calling Nginx. So this is now calling from the cluster 2, and I'm not mentioning anything about like ingress gateway or anything. I'm just simply calling the Kubernetes service itself. Like, so if you look at the Nginx, it's used cluster IP. So in a single cluster, like when you have like multiple services deployed in the single cluster, you can communicate with the cluster IP. Now we are doing the same thing with the cluster 2. So cluster 2, I'm like only telling the service name and the port, nothing else, and I'm able to connect. So in here, if you look at that, the service in the cluster 2 able to identify like which is the cluster IP. Here you can see this is the cluster IP, and it will be like sending traffic. So like I mentioned, like when you have uh, like two services running same port in my local setup, I won't be able to do that because I won't be able to expose the I won't be able to like run port 8080 like for two clusters, because there will be like always a conflict saying that port is in use. But in a general cloud-based scenario, like even if I have another Nginx running in the second cluster, if that goes down, still I only need to call this service name. It will be able to route the traffic. It will be able to identify like which is the IP which is available, and it will send the traffic to that particular service and able to deliver the data. So this is like close communication between the two services. Now let's think about like a scenario where you want to use HTTPS using the ingress gateway. So in here, you have both of the clusters. We have like a external IP. In this case, like more like an internal IP. So let me do a cleanup first. Okay, now we have, let me share the file. Let me know if you're able to see the file. So yeah, so here I'm like a creating like a Nginx deployment, normal one, and I have an Nginx configuration with a simple health point and a simple location, and then this is the port I'll be using, and creating a gateway, and I'm telling this is the gateway for the Nginx, and I want to use the Istio ingress gateway to handle the traffic, and I want the Istio ingress gateway to manage the TLS certificate as well. So in a general scenario, like for example, when you are talking about like a web service, here you will be giving your domain name .com, and then you will be like providing that TLS certificate in here. You can either like it's up to you, like where you want to manage your TLS certificates. You can either terminate your TLS certificates in the gateway, or people also usually does inside the Nginx configuration as well. So it's up to you, like where you want to do the TLS termination. So in this case, I'm like telling I want the gateway to do the TLS termination, and I'm like telling this is the port enabling the TLS, and this is a host. Then the same, I'll be like creating like a virtual service. As a part of that, I'm telling this is the gateway I want to use. This is like normal Kubernetes service. So if you go to the installation script, it's the same thing. For this engineering service, I want to use like a, I'm just generating the TLS certificates from the private CA, which we created in normal production-based scenario. We won't be using this. We'll be using like cloud-based SSL configurations. For the demo purpose, I'm just using, since we already have like a Vault CA, private Vault CA, I'm just using that private Vault CA to provide me a certificate. So these commands are like basically that, and then like creating the secret from these certificates, then applying the configuration files. Then these are like a simple step which you want to like do the test. So let me go back to the terminal again. So now what it does is like I mentioned, it create like a certificate for the Nginx with this name, and then it mapped as like a secret in the Istio Ingress Gateway configurations, deployment services are like created. So if you look at now, so I have an Nginx port running, I have a service running. Again, it used the cluster IP. I'm not using our port or like the service load balancer. Now I have, if you look at the secret, sorry. I have the Nginx TLS secret. Here, I'm creating the TLS secret in the Istio gateway because my Ingress gateway runs in the Istio system namespace. So you can see this is the Ingress gateway I'll be using. And if you look at the gateway, here you can see this is the gateway which we created. And if you look at the virtual service, you can tell like this is a virtual service, this is the gateway you want to use, this is a host. And I want to test it, like how this will be like working, like when we enable the TLS. So in this scenario, I'm like calling the, since we enable the TLS, I'll be like telling, so I'm telling like, yeah, I'm use curl, I use the resolved configuration. I'm telling this is the host name and the port which I want to map to the Ingress gateway IP. Then I am passing the CA chain in here, and then I'm telling HTTPS the service name, the full service name, and I'm able to connect. And this is from my local machine. That means like I'm connecting to the external IP, in this case, like internal IP. It's the same scenario like when it comes to the cloud as well. So like I mentioned, you have like a service, you can deploy the same service in both clusters, and you can tell like point your like nginx.example.com to both of the IPs. So in here, what XLE does is like, here I'm telling this is the service and this is the Istio system gateway. And this will be like a load balancer, like static IP, which we map to the ALB services. So again, like it like when you have like, so normally like they basically like when we do this, there are like a lot of scenarios where the second cluster wants to communicate each other like through TLS. So here, since we have like a private CA and the certificate which I use like from the private Vault CA, that's why I have to pass the CA set. Otherwise, you can directly call the service endpoints. So this is one scenario. So but mostly like we'll be like using not for the external services, it's more like internal services. Like for example, you have, let's say, GraphQL endpoint in cluster 1, and in cluster 2 there is a microservice running, and I want to my microservices want to communicate to the GraphQL service. So where we don't expose the GraphQL service through external IP or like through load balancers. So in that scenario, but still I want to communicate through like in a secure way. So that's where like this is come in place, because I'll be like using the only the service name in order to communicate to fetch the data, instead of like going outside of the external services. You can use the same concept for external services as well, but this concept is like more like for an internal based services. um, so are you able to follow? Let me show the stop screen. Yeah. Any questions?
Yeah, sure. So, uh, like, I think I got a better understanding on what we were discussing, but maybe I think Lakshmanan had a question. So
Okay.
he was not there when you like described, uh, uh, elaborated on that part.
Okay.
So Lakshmanan, like, if you have, if you can just describe your question, like if you haven't understood, please go ahead now.
Yeah. So I think I finally got the idea. Thanks, Vishnu Nair. I mean, see, my question is majorly with respect to the external service actually, but then you rightly pointed out like this scenario, whatever we are looking at, it is actually for more of the internal and not for the
Yeah.
external. Yeah,
Yeah.
I think that
Uh,
answers the question.
yeah, external also, like here we can actually map the external to, like I mentioned. So since it's in my local setup, I wasn't able to like test like where if I can give the same gateway and point both to the same gateway IPs. But in this case, like it's more like when you're
One has to
thinking.
be a master.
Yeah, so one
Yeah.
IP, like when we say like one IP, it's like more like a AWS static IP, like Elastic IP, and then you map that
Mm-hmm.
Elastic IP to your NLB. Because let me go back to this configuration again. Let me 1 second. Let me know like if you're able to see the screen. So this is like our Istio ingress gateway. So here you basically can add like configuration, like for example the annotations, like for example AWS annotations for like internally ALB. I have some, like, let me, I don't remember the exact annotation. 1 second.
Yeah, like work with annotation.
Yeah,
Uh,
yeah, normal ST annotation, and then you can actually tell I want to use like NLB instead of ALB in here. Basically, you can add like a lot of configuration when it comes to the AWS, because AWS have like a lot of annotations you can use in the service level. So basically, you can configure like which of the security groups you want to use, which of the like subnets we want to use. There are like a lot of configurations we can add under this. Like in my scenario, like since I'm using kind, like that's not useful in the demo purpose. So it's the same wise, like we can do it like for GCP as well as Azure. Um, then I have like another demo as well. So let's say like in here, let's think about um, 1 second. So let's say I have the cluster. Like cluster 1 is like in the Europe region, and in the Europe region, like they have like a regulation in place where you don't want to share like PI data to outside of the region. Like for example, I have the cluster in Amsterdam region, and I have another cluster in the US West region. Both of them operates under the same operational company, and the US cluster wants to have some data, but it shouldn't get any PA data. Like for one of the business use case, they want to have some information about the customer details, but it shouldn't be related to the PA. PA means like personal identified information. So it shouldn't be like using the PA data. So let me show you that as well. Let me go back to the screen. So let me do first a cleanup. So now we have. So we'll go through the file. So basically, I'm creating like a config map. It's just like a Python application. I'm like telling this is the database. Like the application will be connecting, and simply it will be writing like few information there. And then this is support I want to be using. Then I am creating like a PV for that data to like mount. Then the normal Python configuration commands which will be like running. Then I am like telling the code and the DB volume mounts, then exposing the service. So when I do this, so basically, like I mentioned, it creates a config map, it creates a PVC deployment and service. Now let's wait for the port to come up. Now I'll be like creating like a port on the cluster 2 scenario. So where cluster 2 is like in the US East region or something like that. So let me create that. So you can think this curl port as like another service or something like that. So from the data rules and regulations, like on the cluster 1, because cluster 1 is in the Europe region. Imagine cluster 1 is in the Amsterdam region, and they have to follow GDPR, and they have to follow the data sovereignty. It shouldn't left the Europe region, and cluster 2 is like in the US East region. So here the US East region shouldn't get any PI data. But if you are not applying any policies, like for example, now when you have like the Istio multiple in place, I am like connecting. So here, let me get the service name. So this is the service, GDPR API. So 9090, and I'm calling the endpoint. If you look at the configuration here, so this is the non-PI data, and this is the PI data endpoint. So I'm just calling the PI data. Sorry. Oh. 1 second. Sorry, I have to follow this one. Sorry.
I think maybe you have to write curl in.
Yeah. So I forgot the call. So here again. So now I don't have like any policy in place, and from the cluster 2, like I'm able to like see both data. So this is like a violation. Like it shouldn't happen, because like when you're dealing with multi-primary cluster, and when you have to follow the data rules and regulations, you have to have like right policy in place. So without the policy, like the services can call any of the endpoint and fetch the data. So now I have like a policy in here. So basically what I'm telling is like we can write, you can use like the Kubernetes network policies or Istio authorization policy. So here I am using Istio authorization policy. Here you have like different ways to write this authorization policy. So I just use IP blocks, because we already know like what are the Kubernetes ports and service IPs, which will be like creating. You can also use service accounts for this. Like you can tell like the service account name in here, and you can tell, okay, instead of like IP blocks, you can configure only I need this particular service account to have access. So there are like different ways to like configure this. So here I'm telling like this is the IP block I want to use, and this is the only this is the action, like allow action, and it can only go to this particular endpoint. And I also have like a deny policy, like if this is support, this is the endpoint, block all the service from this IP blocks. So I'm applying this policy in cluster one. Now, if you try the same previous command, so if you look at the previous command, like here we can fetch both non-PA data and PA data. So now we can use the same command in here. So I get the non-PI data, and if I try this, I should get an access denied because that policy in place. So when you're dealing with like multiple primary clusters, you also need to configure the authorization policies. So this will be like easy for you to like manage and make it sure uh, like only the authorized services can be like talk each other, or the authorized network can be like calling the endpoints. Any question on this? Or any question in general? Like that's a demo. Yeah.
Yeah, that is great. Like this is basically the authorization policy in Istio, right? That particular
Yeah.
source that you showed.
Yeah. Yeah. You can also do like Kubernetes also have like its own object for the network policies. You can also use that. But since we already use Istio for like for multi-primary cluster, I use the same.
Okay, cool. So Vishnu, it was a really knowledgeful and wonderful demo, and we are actually expecting that codes that you shared, all the scripts and everything. If you
Yeah.
could publish that in some Git repo and share those links,
Yeah,
like when
sure.
we are like posting this video in YouTube, we could just add that in the description, and everyone can go and try it out. I
Yeah,
think
sure.
all
Uh,
that scripts to set up kind Istio, Vault, and everything is kind of really useful, like for anyone who wants to do like
yeah, it's like more I would say it's not like a production ready thing, but at least
Mhm.
semi-production, because I'm like making sure like we
Yeah,
want to use TLS in place, we have the right policies in place. Yeah, I can commit it in a GitHub and share the links. So
great. I
it's
think
good
it
to
is.
try. Yeah.
Yeah, I mean, it is something like if anyone want to quickly ramp up a POC setup with a Vault and everything,
Yeah.
you know, I think this is
Yeah, especially,
useful.
yeah. Yeah.
Yeah. So thanks, Vishnu. Thanks for this session. I think many of the people that who joined us have already left by 8 p.m. like
Okay.
around 15 minutes back, but we still have a 12 people around here, and we
Okay.
had somewhat like 20 people attendees like throughout like around 17 and all.
Okay.
Yeah, so guys, if you have any questions, please shoot now. Otherwise, I will just go to the next item that we have. Like I won't take much time, like it will be like 5 to 10 minutes max. So yeah, just shoot the questions. Like if you have any questions, please shoot now. Like I think everyone is good with your session. So
Okay.
just receiving some feedbacks. That's glad.
Yeah.
Great.
Yeah, I think like normally like most of the companies, uh, especially like in startups or like a mid-scale company, people will be like using a single cluster and you'll have 100 of services. But there will be like scenarios when you're working in like a bank or when you work with telecom industry. There are like scenarios more, instead of like more exposed services, there will be like tons of internal services, and they will be like struggling to connect between the internal services because there will be like multiple third parties involved. So it's like uh, multiple third parties or stakeholders involved, and each stakeholders have like their own kind of infrastructure they will be running. So you have to come up with some sort of solution to communicate each of the services in a secure way. So that's where like multi-primary is like more useful. People also use like, there are like instead of multi-primary, people also use like a remote kind of I think, like for example, you have like a single, you have like multiple Istio clusters, but you'll have like a single control plane and like more like a remote control plane where you have the master controls the remote. So yeah, it's a complex thing to work with Istio, but
Yeah,
it's a powerful, like there are
service
like,
mesh is
yeah,
always complex.
there are like lot of things we can do with, like especially you can write your own custom envoy filter. Like for example, you have a service in service one, and then you have to pass certain headers. So you can actually customize with envoy filter to pass those headers. For example, when you're working with front-end applications, you have to pass CSP, like content security policies in place. So you can actually do that with Istio. So yeah, lot of things can be done. Yeah.
All right, let's get started with our next item. I will quickly share my screen. Can you guys see my screen?
Yes.
Okay, cool. So I had this slide shared as soon as I received it when the KubeCon happened last week. So I hope you might all have gone through it, or at least some of them you might, right? And some of them, if you haven't, you might be wondering what these slides are about. So this is a survey that is conducted by a company called Slashdot, and what they did is like, it's a developer survey. So they try to understand for multi-cluster application management and batch AIML compute technologies, which are the widely adopted um, cloud native, like the tools that are available in the cloud native computing foundation landscape. So, uh, so like what are the takeaways from this survey is like if you or your organization wants to do similar things like the multi-cluster application management or do some AML batch processing sort of things, you could actually just refer this survey report and understand like what are the other like the tools and the technologies that other organization uses, right? So you will get a fair understanding on the maturity level of those tools and technologies. So let's just get through this quickly. There are not many slides, and I will probably skipping most of them. Yeah. So like it's a copyright notice you're seeing here. I have to say this, otherwise it's a copyright infringement. So this is a survey report that is created by Slashdata, and this is sponsored by Continuous Delivery Foundation for this particular survey. And these are the two analysts that who did this survey, Liam Dodd and Bretton Knoll. So the key insights, let's just go through this slide and maybe skip the other slides. So the key insights here, as you can see, for the multi-cluster application management technologies, Argo CD and Cilium were considered the technologies that are ready to adopt. So I know, like I personally feel like a good connection with Argo CD. Like many environments, many projects that I have worked with in the past, we have Argo CD used very widely. And I feel the same, like wherever I go, wherever I talk with the peer group, like they all are like, majority of them are with Argo CD, and some of them use Flux CD, but yeah, majority of them are Argo CD. And I have never heard any other tool that they use to deploy applications to Kubernetes cluster. And Cilium, likewise, Istio, like it's also service mesh. And this is something I don't know, like maybe Cilium is based on eBPF and Istio is something different. Maybe that's why people are more adopting Cilium nowadays. But yeah, so there are many people that are using Cilium, and they feel like more happy with Cilium now. And yeah, and then for batch AEML computing technologies, Apache Airflow stood out, and that is majorly because Apache Airflow had a huge adoption in the past by the data engineers for doing the batch processing and running DAG flows. And the other tools that also inline is kubefs, kubeflow, and fluid, and these all were placed in the adopt category of the technology radar on this particular survey. So yeah, that's pretty much the takeaways from this. So if you go through these slides, you will see okay, so this survey is conducted among 300 professionals, working professionals. Most of them are like 51% of them are like working in a cloud service provider or cloud consultancy services sort of companies, and the other majority, like other part of the total crowd is they are mostly working into data specific items. So that is the demographics of the developers, those who have participated in this survey. So you can see here Argo CD, how it is in adopt state and other trial, assess, and hold states. So you can see the other tools that could deploy to same application to different cluster environments. You can see that here. So if you want to learn more about, just Google them and you'll be able to find more about each of the tools. I'm pretty much like my personal opinion, I feel pretty much happy with Argo CD for the multi-cluster application deployment. This is for Cilium. It received highest useful score +50, as well as received non-negative 1 or 2-star ratings. And other tools have, there are Armada and Clusterpedia. They have received 2% each. And I really don't want to get into detail and stop you here. But I think, yeah. So if you can spend some time and go through this survey and get some understanding. So basically, this is it: Argo CD, Cilium, Apache Airflow. These are the tools that they find very useful. Majority of the developers are currently using it, and they voted that like this is very useful, and we are pretty happy with using these particular tools and technologies. So yeah, that's pretty much. If you have any questions, please just comment. Otherwise, let's try to wrap up this session.
I shared the repo link and the PDF in the chat. So in case if anyone wants to play with it, please feel to.
Yeah, just copy it. Okay. All right, guys. Let's connect again in our other coming up the meetups that are coming up. So Vishnu, thanks for the time here, and I am again saying the session was really wonderful. It was what the people who have attended. I feel the same. It was really knowledgeable, and it's worth attending this session. And even if someone have missed this session, I think they will find valuable the recordings and everything. So we'll be publishing it, so people can actually come back and look at it if they want to try it out by themselves.
Yeah. Thanks a lot. Thanks a lot for the invite, and it's nice to be part of the community. So yeah.
And once again,
like in case if you have any questions.
yeah. So once again, thanks for everyone, those who have joined with us today. So we are really looking forward again in the future meetups, your participations and contributions. Thank you all. Yeah.
Yeah, I just shared the LinkedIn profile as well. Yeah, bye.